improve the lives of the people around us. Innovarex Global Health ushers in a new way of leveling the playing field with increased access to quality healthcare services delivered at your doorstep. Our qualified professionals are equipped with state-of-the-art point-of-care testing technology to conduct tests such as kidney function, liver function, electrolyte tests, body composition, hemoglobin, A1C, and many more services with the highest efficiency in delivering results. The addition to our flagship Wellness on Wheels, more fondly known as WOW Delivery Service, brings the entire clinical experience full circle. IGH has remained committed to creating the future of healthcare delivery. Gone are the days of sending loved ones outside the country for basic medical services. Innovarex Global Health offers a new peace of mind and takes pride in delivering the quality of care we all deserve.
With whatever we do, Jioni safu nola. With whatever we do, haleyi demunyu skula. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin te jibe norin te nyamen Lamin.
Kabona wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumara kan kuma diteng.
Fabrama.
Jumara mu.
Ndele bare muso.
Lunda mbara.
Kamo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mundu wa kontan.
Ngoto minaka ngalamin de fom filitala. Lamin jibe nori nyala.
Lamin ida siram sama ne benki. Yala so tol sayni no ko mo lokko momo.
Ngoto.
Nam.
Iterinte yalo ne Lamin hakilo diata bake karambu ngoto. Anu santeng ministry ko di ngole si suwo ko amanke ko do holiday la
si bitun
bagona de
ala ni ko kede namo balo
ala ni na ko ina karta bulo be damen ala ni je
ngoto
nam
ngoto mon kontan feren
jamani mu nekata
ifika Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karambu wol ma soron ni ko karambu wol soron da amanke ko holiday lem ngoto dini wonyanta sila la ala karango la moy yamen kaben fue man kontan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol soronda doron kamen courant ma rado la kombo e ko ndol fana na kara mol soronja e kara mol soron Lamin ada lo nyino la amanta ra fena sokon ala munekela
Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko yana di mod Lamin ya muna fonye
bir kabin mina kan ntambita nteri maning Fatou ntambite la sukol ala dinngol bebe siri be la moyka
Fatou danso am fana tambira jele ni subala la ngaje dinngol be jet talanta nen kili warol e be seri jelet
sa Lamin fadante ku kili wo ke no la ba Lamin bitaka wulo ko no nyinta mo Lamin
amandara fenela
ite dine ko ni man si yakari lesinol la moy radio to e balon na
muneka ke afonde ba nyara ni alon
telentel jikot
afonde ba munebe ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya e tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin manya tala wulo ko adu karam wolbe so da fanya membe kala
ko to wole nati ba ngal le ni Lamin kuntal kombo courant o ka fa me kombo courant asototal wala kinai ko esi suwo kono bari ni ko si so kono ibe karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bungo bar radio be bulan koto batiri sanga ay si ay alama
sa do kala nyaadi
ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandi
ila subject ro baby jele baby jele
wala nanga chocho moy fa dan so wolya ngombe tambi kana ngadi ningol je be ikadum bungo de ko kada ma
asota talde
la min mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko ndé ko folle sini lamba ndé le sini no ne ba
mba say mba foke en koto wole fango yen mulindi yalo famo keta bat ñu fanam bulata ko ko me yen nati jambi la min nyanta karana ndel be jiko be nyine ka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje koto dindi ngoy si ayala le sino la moy radio
wora ka munda kara mo man soro la min nyanta kara si so na radio
la sila le ayala le sino
ndani ko korno ko smolon
kilar ya
mo be ngala ko momo say mi do ni fono kera
mengi bruso
ndelo ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man nembe buljan dala nyara nyar wo ko fendi mo la ba min tayra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
imagine nañu ñambol si zol le keje kisigi man si zol ndol le kafun ka ñoma bari ñambu kino li mañana ka finde ni nambe ko zol la ga
ngalle limbeta de be ñambo do dilanna
ñara ni ko rim fennat ñara nata
bari famo ke da
ngata bun kono tammi bun kono ñara mel ngando ko fele ko ke baru ngana ni pelo la ndija
iyo awa better la
bun kono bismillah bisu diara
pendulala yefungo tanka sina dolu tanka koro korota korota
Hi everyone, I am Mr. Babukar Aw, your chemistry tutor, and today our lesson will be based on thermochemistry, and then this thermochemistry is one aspect of energy, but we will not be discussing about all types of energy. Therefore, we will just focus on the heat energy, and then we use the term thermo to replace the heat. That is heat chemistry, or you can simply say thermochemistry. And our contents are: one, definition, that is we will try and define thermochemistry. Two, basic terms and also what types. That is the basic terms we will be using throughout this course, and also the types of the terms. Three, enthalpy change or heat change. We will also discuss about enthalpy change or heat change, and this will include both endothermic and also exothermic reactions. And four, we will have our assessment. Now, thermochemistry, this is the branch of chemistry that deals with the study of the measurement, interpretation, and analysis of the heat changes accompanied by chemical reactions. Now, because every chemical reactions must be endothermic or exothermic reactions, which means there must be heat change. That is, if you are able to differentiate between a physical change and a chemical change, one of the differences will be there is heat change in the chemical reactions. So some reactions, as they are taking place, they will release heat, and then we term those reactions as exothermic reactions. And some reactions, as they are proceeding, they will need to gain heat or gain energy from the surrounding, and then we term those reactions as endothermic reactions. And then we will study how to measure and interpret these heat changes. That is the what? Energy change which is involved in the chemical reactions. Now you have the basic terms. Now the first one there is energy. And then we said energy is the ability of a system to do work. Now anything that can give a body or a system the ability to do work is termed as what? Energy. It's termed as energy. It can be living thing or non-living thing, because we know there are many non-living things that can initiate energy into systems. And then we have various types of energy, and one of them is called the useful energy. And the useful energy is the energy used to perform a particular task. Any energy that is used to perform a particular task is termed as what? Useful energy. And B, we have primary energy. Now, primary energy is the total energy needed to supply useful energy. It can be renewable or non-what? Renewable. That is the total energy needed to supply a useful what? Energy. Because we know that the useful energy is the energy used to perform what? A particular task or a work. Now, the energy that is needed to supply the useful energy is termed as what? The primary energy. And then it can be what? Renewable or non-renewable energy. Now, the renewable energy, this is the energy that comes from natural sources that are constantly and sustainably replenished. Example, sun, water, wind, tides, and also biomass, etc. Now, for example, you use the energy from the sun. Maybe use it on Monday. You cannot say that, let me go on Tuesday to use this energy before other people will come and what? Finish it. Because the energy from the sun is what? Renewable. It is natural. Any radiation emitted by the sun cannot decrease the amount of radiation possessed by the sun. So the energy in these natural resources are constant. Again, you have water. For example, if you have the water bodies like the seas, rivers, oceans, you go there and just collect a bucket of water. That bucket of water cannot show any change on that water body, maybe from the what? Ozone. You cannot notice, I have removed a bucket of water from this ozone, because that water body, which is the ozone, is an example of what? Renewable energy. And the same thing applies to the wind, tides, and also biomass, etc. 2, we have the non-renewable energy. A resource of economic value that cannot be readily replaced by natural means on a level of equal to its consumption. A resource of economic value that cannot be readily replaced by natural means on a level of equal to its consumption. Example, energy from what? Fossil fuels. That is oil, coal, and also natural gases. Their use is not sustainable because their formation takes billions of years. For example, the formation of crude oil, which is from the what? Fossil fuel. Now, any amount of oil that is collected from the wells containing this crude oil, that crude oil is not readily replaced because it is a form of non-renewable energy. And their formation takes billions of what? Years. Therefore, if you have a well containing crude oil, time will come, there will be no more oil in that particular well, because the energy contained in that well, which is the oil or the crude oil, is an example of non-renewable energy. Now we also have another term, which is surrounding. Now we said this is the area outside and around a system. Now, and then the other term is boundary. Now, boundary, this is the wall that separates the system from the what? Surrounding. If you have a system, there must be a boundary between your system and the outside wall. And then the outside wall, in that case, is termed as the what? Surrounding. Now, the border between the outside wall, which is surrounding, and your system is called the boundary. Another term is called a system. Now, this is any part of the universe that is under study. It could be living or non-living thing. Anything that is under study is termed as a system. Now, for example, I have this container, and I term this container as a system. Now you see, this container is my system, and then the walls of the container is the boundary of this system. Now anything outside the system, apart from the boundary, is termed as what? Surrounding. Is termed as surrounding. Now note, a system can be what? Simple. For example, water in a beaker or water in a what? Container like this. Now, this is what? An example of a simple system. Now, the second type of system, or a system also can be complex. And then the example is polluted water in a pond or what? Ozone. That is polluted water in a pond is termed as complex system because there are many, many reactions that are taking place, and these reactions could include both chemical and physical. And also the water in what? In the ozones, because we know that we don't have pure water in what? In ozones. But there are many, many, many other impurities contained in these ozones, and many, many other substances that are living in what? In these ozones, which makes water in the ozone to become complex. A system also could be uniform composition, and that will fall under the homogeneous. And uniform composition like salt water solution. If you have salt, you dissolve the salt in water, because we know many, many salts like sodium chloride, it's soluble in water. It can easily form salt solution, and this salt solution now will be an example of homogeneous system. Systems also could be heterogeneous. Example, differentiable composition like chalk powder in water. If I have my chalk powder and I dissolve the chalk powder in the water, immediately I stop stirring, you'll notice that the chalk powders will be what? Sinking at the bottom of the container, to show that chalk powder does not evenly mix with water. So therefore, this will be what? An example of heterogeneous system. Now we have types of systems. Types of systems. And number one, we have open system. An open system is a system with boundaries across which both matter and energy can pass through. Example, water in an uncovered container, oceans, rivers and ponds, etc. and etc. For example, I have this container and then the container is open. See, I have a matter inside the container, which is the water, and then the container is what? Uncovered. In this case, if I turn this container, the water will pour out, or even if I leave it like this, energy is still what? Passing through this what? This container. And you can prove this using what? Cold water or using hot water. If you put cold water in this container, time will come, the water will be what? Warm. Or if you put a warm water in this container, time will come also, the water will no more be hot as it was. So this container will be an example of open system, because matter can pass if I turn it, or if I leave it like that, energy can also what? Pass through. And then we say the examples are water in an uncovered container like this one, oceans, rivers and also ponds, because oceans, rivers and ponds are not what? Covered. So they are all examples of open systems. Or closed system, this is a system with boundaries across which energy can pass but not matter. Which energy can pass but not what? Matter. Example, water in a sealed container and calorimeter, etc. For example, I have this container. See, the container is closed now. I have sealed the container. If I turn it, the matter inside will not what? Pour out. But then, energy is still what? Passing through. Because this boundary cannot hold the energy possessed by the matter inside the container. So therefore, this container is an example of a closed system. Number three, which is the last type of system, is called an isolated system. An isolated system is a system with boundaries across which both matter and energy cannot pass through. Example, cold water in a cooler or hot water in a thermos flask. For example, we have this thermos flask. I see this thermos flask is having what? Boundaries. Yes, it's having boundaries. That is this. And then it is what? Closed. You see, it is closed. And then we know these thermos flasks are made in a such a way that they will be able to what? Retain the energy possessed by the liquid you put in there. So if I put hot water in this thermos flask, the thermos flask will be able to what? Retain the energy possessed by the what? Water inside. If I turn it, the water will not pour out because it is what? Sealed. And then the boundaries are made in such a way that it will be able to what? Retain the energy possessed by the liquid. Therefore, this kind of system will be an example of isolated systems. So we have three main types of system, and then the first one we said it is called open system, and then the open system is a system in which matter can be lost and also energy also can be what? Lost. And then the second type of system is a system in which energy can pass but not matter. It can retain the matter but cannot retain the what? Energy. And the third type of system is called isolated system, and this isolated system, both the energy and the matter can be retained by the container. Now we have enthalpy change or heat change. Now this is the amount of heat evolved or absorbed in a reaction carried out at constant pressure. You see, heat evolved or absorbed when enthalpy change or heat change occurred and heat is evolved. We said that system or that reaction will be type of exothermic reaction. And a reaction in which heat is absorbed will be an example of endothermic reactions. Now note, enthalpy change of a reaction is represented as delta H. That is, you have a small triangle, capital H, and the triangle means delta H. B, delta H is calculated by subtracting the total energy of the reactants from the products. That is, delta H equals to energy from the products minus, that is, subtractive energy from the reactants. That is, delta H equals to E from the products minus E from the reactants. C, delta H has a unit of kilojoules per mole, kilojoules per mole at constant pressure. And D, delta H is experimentally determined by calorimetric methods using a calorimeter. And then in this case we have many types of calorimeter, and then we will show the model or the diagram of one of the type of calorimeter, which is bomb calorimeter. E, the delta H value is directly proportional to the amount of substance, that is, doubling the reactants double the what? Delta H. That is, if the reaction is proceeding and the reaction is emitting heat, the more reactants you put in this reaction, the more energy release or the more heat evolve. That is, the delta H value is directly proportional to the amount of substance. F, delta H signs changes from negative to positive or from positive to negative. And in this case, if the reaction is at equilibrium, which means it can proceed both in the forward and backward direction. If the forward reaction is negative, which means exothermic reaction, therefore the backward reactions will be endothermic, which is positive. Or if the forward reaction of a system is positive, which is endothermic, therefore the backward reaction will be negative, and that is exothermic. And here we have a diagram of calorimeter, and this calorimeter is called boom calorimeter. And on your left is where the thermometer is inserted, and on your right you have poles or electrodes, and then you have the ignition wires. These ignition wires are attached to the poles or the electrodes. Now, down this calorimeter at the bottom is where you have what? A container which is holding the electrodes. And inside the container is where you also have oxygen. And the oxygen is from the atmosphere. You can have atmospheric oxygen there. And also you place your what? Your sample in this container. And then the calorimeter is filled with water in order to minimize or to prevent heat loss. If you use this system, that is the calorimeter, you can be able to measure specific heat evolve or absorb from a body. Now we have endothermic reactions. These are reactions in which a system absorbs heat from the what? Surrounding. A system which absorbs heat from the surrounding. Now note, a system, that is A, the system absorbs heat from the surrounding because more energy is needed to break the bonds in the reactants than to make new bonds in the what? In the products. Now to summarize this A, the energy possessed by the reactants in endothermic reaction is not enough for this reaction to overcome the activation energy and form products. And before products are formed, the reactants must have energy equivalent to the what? Activation energy, so that they are able to overcome the activation energy and form the what? Products. B, the minimum amount of energy required to break the bonds in a reaction is called activation energy. Again, if the reactants do not have energy equivalent to the activation energy, they cannot form products. Because energy equivalent to the activation energy will make bond breaking possible. And if there is no bond breaking, there will not be bond formation. Therefore, reactants must possess energy required to break the bonds in a what? Reaction. C, activation energy is the minimum amount of energy required for a reaction to take place. Because if the reactants do not possess energy equivalent to the activation energy, there will not be no reaction. And if there is no bond breaking, there will not be what? Reaction. Because no products will be what? Formed. And then we said in a chemical reaction, new compounds are formed. And new compounds are formed only if bond breaking in the reactant side is possible. D, in endothermic reactions, the energy of the products is higher than that of the what? Reactants. And then we will show this using the endothermic diagram. That is E, the enthalpy or heat change, that is delta H, for endothermic reaction is positive. Because the reactants in endothermic reaction do not have enough energy to form products. So they need energy from the surrounding so that they will add it to the energy content and they will have energy equal to the activation energy, and therefore bond breaking and bond formation will be possible. And here we have the decomposition of calcium carbonate, and it forms calcium oxide and also CO2. And the delta H in this reaction is positive 171 kilojoules per moles. And then we have a diagram to show the energy profile of endothermic reaction. Now you see the R is on the left and the P is on the right. The R represents the reactants and the P represent what? The products. Now you see the energy of the products is higher than the what? Energy from the what? Reactants. Now the distance between the what? Reactants to the end of the graph, to the edge of the graph is termed as activation energy. And that edge of the graph is called activated complex. Activated complex. Now you see in this case, the reactants is just possessing what? 5 kilojoules per mole. And the activation energy is 20 kilojoules per mole. Therefore, they cannot form products. They need more energy from the surrounding so that they will have energy equal to the 20 kilojoules per mole, and then the formation of the products will be possible. Now, examples of endothermic reactions. 1. Photosynthesis. 2. Dissolution of sodium chloride in water. 3. Dissolution of ammonium chloride or ammonium nitrate in water, that is dissolving these salts in water. 4. Dissolution of blue hydrated copper 2 tetraoxosulfate 6 in water. And 5. Decomposition of water into hydrogen and oxygen atoms. That is, you have water is decomposed and form hydrogen gas and oxygen gas. And the enthalpy change, that is delta H in this case, is plus 285 kilojoules per mole. Now the last type of system we will discuss today will be exothermic reactions. Now these are reactions in which a system liberates heat to the surrounding. Here, the reactants have enough energy to form products. So therefore, they will release some of the energy they possess so that their energy now will be equal to the activation energy, and then bond breaking and bond formation will be possible. Note, A, the system liberates heat to the surroundings because less energy is needed to break the bonds in the reactants than to make bonds in the what? In the products. That is, the energy possessed by the reactants is more than the energy required to break the bonds. So therefore, before bond breaking takes place, energy is released from the surrounding. And finally, products will be possibly formed. B, in exothermic reactions, the energy of the product is lower than that of the what? Reactants. That is, the energy of the product is lower than the energy of the what? Reactants. That is, again, the product will have a lower energy compared to the reactants. That's why, if you use the formula of the delta H, you will have a negative value for the exothermic reactions. C, the enthalpy or heat change, that is delta H, for exothermic reactions is negative. And the example we have here is combustion reaction. That is the reaction or the burning of carbon in the presence of air, which is oxygen, will lead to the formation of CO2 gas. And the delta H in this case is minus 393.5 kilojoules per mole. And this is an example of exothermic reactions. And then we have energy profile diagram for exothermic reactions. Now we have a graph, and on the vertical axis we have potential energy, and the horizontal axis we have reaction pathway. On our left we still have R, which represents the reactants, and on our right we have P, which represents the products. Now you can see that the energy possessed by the reactant is slightly more than the energy possessed by the products, which will make this reaction to be negative. And where you have the EA, that is EA represents what? Activation energy. That is the energy between the reactants to the what? transition state. And that transition state is known as activated complex. The transition state is known as activated complex. Now, again, we have another graph, and this graph is showing the effect of catalyst in these exothermic reactions. Now, this graph shows the composition of glucose both with and without a catalyst. Notice that the energies of the reactants and products are unchanged by the catalyst. Now, if you put catalyst on this kind of system, the catalyst will not change the energy possessed by the what? Reactants or the energy possessed by the product. The catalyst is just there in order to reduce the activation energy so that products are easily formed. Catalyst affects the rate of chemical reaction by decreasing the activation energy. And this is for what? Positive catalyst. And then finally, we have our assessment. And then question 1 reads, the activation energy for the forward process in this reaction is. Now you look at the graph and then you try to answer the question. And option A reads plus 15 kilojoules per mole or 15 kilojoules. B reads negative 15 kilojoules. And C is plus 25 kilojoules. And D is negative 25 kilojoules. 2. The activation energy for the reverse reaction is thus. Again, you can know the correct answers in this question by looking at the graph again. And A is plus 25 kilojoules. B, negative 25 kilojoules. C, plus 40 kilojoules. And D, negative 40 kilojoules. And question 3 reads, what is another name for the activated complex? A, energy barrier. B, transition state. C, rate limiter. And D, collision group. 4. At what state of a reaction do atoms have the highest energy? At what state of a reaction do atoms have the highest energy? And you can answer this question by looking at the graph. You can look either the endothermic or the exothermic graph, and then you can see or you can check the highest energy attained by the reactor. And A reads reactant stage, B reads product state, and C is transition stage. Now with this, we come to the end of the lesson. Now, see you in our subsequent videos so that we will answer the questions together. Bye.
We live in a day and age where technology is creating a world without borders, filled with unlimited potential to improve the lives of the people around us. Innovarex Global Health ushers in a new way of leveling the playing field with increased access to quality healthcare services delivered at your doorstep. Our qualified professionals are equipped with state-of-the-art point-of-care testing technology to conduct tests such as kidney function, liver function, electrolyte tests, body composition, hemoglobin, A1C, and many more services with the highest efficiency in delivering results. The addition to our flagship Wellness on Wheels, more fondly known as WOW Delivery Service, brings the entire clinical experience full circle. IGH has remained committed to creating the future of healthcare delivery. Gone are the days of sending loved ones outside the country for basic medical services. Innovarex Global Health offers a new peace of mind and takes pride in delivering the quality of care we all deserve. Will it?